Okay, so this is part 2 of 4-7, and we've already looked at inverse sine and inverse cosine, but now we're going to take a look at inverse tangent. Now, our graph of tangent, we have asymptotes at negative pi over 2 and positive pi over 2. And then our quarter points here are at 1 and negative 1. And this is a period of just pi, and this is what our tangent graph looks like. So this is y equals tangent of x. So it's a lot different than our sine and cosine graphs. One period of tangent passes the vertical line test, so tangent's a function, but it also passes the horizontal line test, so inverse tangent is a function on one period. Now, if we had several periods of tangent lined up, then it would not pass the horizontal line test. But on the restricted domain, from negative pi over 2 to positive pi over 2, and notice I'm using parentheses because those points are not defined, there's asymptotes there, we have an inverse tangent, so on this restricted domain. So, looking at our domain and range, our new domain, well, if we flip this over, if we switch those coordinates, inverse tangent will look like this. It'll almost look like the cube root function. And so our domain would be all real numbers, so negative infinity to positive infinity. And this is for inverse tangent. And our range is going to be from negative pi over 2 to positive pi over 2. And again, notice we don't have the equal to signs because it won't be defined there. It'll go all the way up to negative pi over 2, or to positive pi over 2, all the way down to negative pi over 2. So let's kind of summarize and take a look at some of the information that we've used here. Let's look at tangent of x. And so I'm just going to copy that graph that we just looked at. So just quickly, we have asymptotes there, and this is what tangent looked like. So this is for tangent. Our domain is from negative pi over 2 to positive pi over 2, not including those values. And our range was negative infinity all the way up to positive infinity. So these will switch then for inverse tangent. Our domain will be negative infinity to positive infinity, and our range will be negative pi over 2 to positive pi over 2. And our graph now has horizontal asymptotes at pi over 2 and negative pi over 2. And our graph will look like that. So that's inverse tangent's graph. Now, talking about evaluating inverse tangent like we did sine and cosine, let's go ahead and fill out our table here. So tangent at negative pi over 2 is undefined. That's where our asymptote is. Same thing at positive pi over 2. At 0, it's 0. At negative pi over 4, it's negative 1. Positive pi over 4, it's positive 1. And then at negative pi over 3, we have negative root 3, negative root 3 over 3, root 3 over 3, and root 3. So now evaluating inverse tangent of root 3, we're asking ourselves, well, at what angle does tangent equal root 3? Well, tangent of theta equals root 3 when theta equals pi over 3. Okay, and that's on the restricted domain. So that's an example of how we would evaluate. Now between part 1 and part 2 of these videos, we've gone over a lot of information. So let's just summarize everything that we've gone over so far. First, let's take a look at sine of x. Now, sine of x, we said, had a restricted domain of negative pi over 2 to positive pi over 2. And we had brackets because we could include those values. And normally, one period of sine is from 0 to 2 pi. Okay, that's what normal sine is, not inverse sine. Okay. And cosine, we have from 0 to pi, and again, this is for inverse cosine, and from 0 to 2 pi for regular cosine. And then for tangent, in the restricted domain is the same as the period, negative pi over 2 to positive pi over 2, and regular tangent of x is the same. Now this information is going to be really important to us to know what values we're looking at for these inverse trig functions. Now let's summarize what we talked about with their domain and range. So we're going to do the same thing with their graphs. This was y equals inverse sine of x. And remember that the domain went from -1 to 1 now, and up to pi over 2 and negative pi over 2. And this is what inverse sine looked like. Our domain and our range. Our domain is from -1 to 1, x values, and our y values were from negative pi over 2 to positive pi over 2. Okay. For cosine, we had from -1 to 1, and we went from 0 to pi. Okay. So we start over here and over here, and our graph looked like that. Our domain and our range. Our domain is from -1 to 1. Our range is from 0 to pi. Okay. And then summarizing tangent, y equals inverse tangent of x. We have pi over 2 and negative pi over 2. And we have asymptotes right there. And this is the shape of our graph. And then our domain and our range, we have negative infinity to positive infinity and negative pi over 2 to positive pi over 2. And again, we're using parentheses here because there's asymptotes there. They're not included. Our domain is all real numbers here. So that's a good summary of everything that we have gone over in this section so far. And there's really only a couple other things to talk about. Now, everything we've been doing is for exact values. We haven't used a calculator at all. And so now we need to kind of talk about how to do this with our calculators. So, looking at our calculator paper here, there's some instructions here in your book about how to do inverse sine, cosine, and tangent. I'm going to just go straight to the next page and do some examples, but if you need some help knowing how to do this with your calculator, this paper would be helpful. Okay. So, inverse properties of sine, cosine, and tangent. We're not going to worry about the other trig functions, but what we need to look at here is if I have sine of inverse sine, those are opposite operations. Just like in chapter 1 or chapter 2 when we saw how to do plugging an inverse function into another function when we had f of g of x and g of f of x. If those both equaled x, then f of x and g of x were inverses. Okay. Well, we're going to do the same thing, but with trig functions. These are inverses of one another. Sine is the inverse of inverse sine, and so on. Now, what we should get here is if we're taking sine of inverse sine, then we're going to end up with a length. Something like square root 3 or root 2 over 2, a value length, like the length of a triangle. If we do inverse sine on the outside and regular sine on the inside, we're going to get an angle as our answer. And that'll be between here, and then these lengths would be between -1 and 1. And the same thing is true for cosine. So if we have cosine on the outside, inverse cosine on the inside, we're going to get a length. And then if we do the opposite, we're going to get an angle. And these are the ranges that those values will be in. And then for tangent, same thing. And angle on its domain. Okay. All right, so let's go ahead and get into some examples here. So here we have regular cosine on the outside and inverse cosine on the inside. So that's like this first one right here. So we're going to get a length. Well, that length that we're going to get is 0.6. It's equal to whatever you had in here. So our answer here is just 0.6. Okay. Now here we have inverse sine on the outside, regular sine on the inside. So we should be getting an angle between -π/2 and π/2. So we can't just say 3π/2 because that's not on this domain. So what I'm going to do is I'm going to first say, well, it's just equal to x, which is 3π/2, but it needs to be on the domain -π/2 to +π/2. So then we should have what's the same angle between there? Well, -π/2 is the same thing as 3π/2, so -π/2. Okay. Remember, 3π/2 is right here. That's also -π/2, and that's why we went with that, because it's on this domain. Now these last two examples probably look a little bit scarier, maybe a little bit different, because now we have different trig functions. So we can't just use the same tools that we used up here. We have to think about these a little bit more. So inverse tangent of 5/12. Well, we need to think about this for a second. One, tangent goes from -π/2 to +π/2. So we're talking about quadrants 1 and 2. This is a positive value, so we have to be talking about quadrant 1. And so we have some angle where the opposite side is 5, the adjacent side is 12, and using the Pythagorean theorem, I could find my hypotenuse is 13. Now we know the answer to this is going to be some angle theta. We know that our answer will be an angle. Well, let's just put theta in there, okay? So we know that this is going to be theta. So cosine of theta in this given information, well, cosine is adjacent over hypotenuse, and that'll be our answer. Okay. Now we can do the same thing for the next one, but its setup is going to be a little bit different. So we have inverse tangent of -5/12. So now this is a negative value. So again, just like what we did here, it has to be in one of these two quadrants since tangent goes from -π/2 to +π/2. And since it's negative, we know it'll be down here. So we have 5 and -12. And then this is 13 again. And our angle theta. And so cosine of theta, well, cosine of theta right here is still positive because cosine is positive in quadrant 4. So this would be, again, 12/13. Oh, you know what? This is 5 and this is 12. This is the adjacent side.